Reason, when there's a minus in the middle, that's when things get freaky. You actually have to kick a negative out. Here, it wasn't a minus in the middle, so I didn't have to worry about that. Negatives always find a way. Right, sort of like Jurassic Park. They always find a way. So then what comes out of both? 5 plus x. So then what's left?
3x minus y.
Is that the same as what we just got earlier?
Yes.
There's the 3x minus y, and there's the 5 plus x. Alright. Of course, Matt, I don't care that Matt, this is the same number as this. If I make x 7 and y 4, this is a number and that's the same number. They have to factor the same way.
Can I do the last one? Last step, how you do it?
So you're cool up to here, right?
Okay.
So then what is this term and this term, what do they have in common? 5 plus x. So I take it out.
But you only want to take it out once, like the other guy just disappears?
I love it. Okay. Because I always get somebody put like a squared there.
You're going to multiply it?
Exactly. So it's kind of like, what's this? If you simplify this, what do you get?
Y.
2y plus ay.
How many y's are there actually? 1. How many does it look like now? 2, because you had 1 that you distributed to everybody. So I don't have 2 5 plus x's, and I continue to make it sound like I'm insane. Jeff, there's 1 there, and there's 1 there. No, there ain't. There's 1 that was distributed to both of these. So there's really 1 when I take it back out. So you don't put a square there. It doesn't make any sense. They don't both have 2, they both have 1. It's a good question, though. I always forget things. All right, maybe. And again,
the minus, it's the problem.
yeah, the minus. Yeah. That's why when I have a choice, I try to not let that be negative.
Okay.
Yeah, that'll become important again when we do another form of factoring here in a bit. Okay. All right.
There will be problems like that, so you just have to remember.
Oh yes, there will be.
Right?
There will be blood. No, there will. Yes, there will be problems. Like, look at that. I'm easily satisfied. Okay. Let me let you guys try a couple of those. Start over my Roman numerals. Oh yeah. When I was in grad school, this is one of the worst things to see. When a teacher wrote down on the board, it was exercise left for student, and we're all like, oh shit. That means we have to do it. Okay, so here you go. You guys do this problem. I'm not going to tax my brain. I'm just going to take some out of the book here. Because it's not always easy to make some that work. Oh, so far.
Did you play the water?
Oh yeah, I forgot. Yesterday was so weird. Oh, let's see what else we can do. There we go. Yeah, these are not too bad. The ones the book gives you. Alright, let's do that one. So this form of factoring is called grouping. And can somebody remember what I said? When do you use grouping? When you see...
Everything's done.
No? How many terms?
4
or more. I love it. So when I see 3 terms, there's going to be a procedure that we learn. When I see 2 terms, there's going to be a procedure that I learn. So the problem is telling you what to do. That's awesome. If I see 2 terms, oh, the problem's telling me to try one of these things. Okay. So when you see 4 or more terms, you do this thing called grouping. Oh yeah, that first was a little bit weird.
Yeah.
Let me help you out a little bit. What can come out of here?
X0. Oh, wait, sorry.
Nothing, right? But what can always come out of anything? One. So whenever something doesn't come out, you write it like this. I'll help you out a little bit there. So it looks more like what you're used to. When nothing can come out, you're wrong. One can come out. So that's how you write. So now you guys do the first part, and then you'll see how it matches.
X2, X plus 6.
Yes.
X squared plus 4. Right?
Oh, okay,
So if you know some factoring, it's a sum of squares. You can't factor. Don't worry about it. It's not part of what we're doing here. I don't know if you guys got. Did they send the email out about those factoring workshops or this? I'm not even sure if that. I wish they put dates on those things.
This is April 12th, 13th, and 14th.
I know, but like, is it 2015 or 2006? Because there's some of those in rooms that are left over. So they should have some factoring workshops. I'll double check the dates if that's the right dates. Unfortunately, I think that's kind of sucks for us because our next test is April. What is our next test? 16th? 19th. Oh, good. So if those dates are right, that's just in time. Okay, let's look at this first problem real quick. I know some of you guys got to finish the second problem up, but what comes out of these two? Squared. So you're left with
X
1x plus
plus 6.
6. And you know you're on the right track because these are,
The same.
if they're not the same, you can't do anything. You've done something wrong or it happens to be prime. Right? When you try to factor a number, you can't. It's a prime number. So if you try to factor this and you can't, it's a prime expression. You would just write prime. Don't write prime a lot because there's not many of them, right? Okay, maybe. So then what's the next step?
X plus 6.
Yeah, you can take an x plus 6 out and you're left with
X2, 9 plus 1.
x squared plus 1.
Oh, we have X squared is not correct. I mean, we have to prove.
Yeah, if that wasn't there, when you check it, you just get x cubed plus 6x squared. Where'd this poor guy go? That's what that does. It lets this multiply with that so you get one of them. It's like a placeholder, or it has to be there because x plus 6 divided by 1 is 1. I mean, x plus 6 divided by x plus 6 is 1. Alright, so here you got to be careful because of that evilness.
Yeah. Not getting the same.
Oh, duh.
Number one, I did it differently. I just kind of moved the numbers and I got x squared and then x plus 6 in parentheses. Is that the same thing?
So, how did you just,
I
did you,
rewrote it.
okay.
X squared plus x plus 6x squared.
Let me catch up to you, hold on. So you rewrote this as what now?
X to the third plus x plus 6x squared plus 6.
I love it, cool. And we just said that's completely allowed. You have to end up with the same answer though because it's the same number. I just rearranged some of its parts. So it's got to factor the same way. I don't care how you arrange it. So here I could take out
X2. X.
right 1x, and here I can take out a 6, and then look here.
Oh, I just didn't put plus 1.
You still get the same answer, right? Notice something. Where we got x squared plus 1 in the answer, right? Where was that here? Where's x squared plus 1? On the outside. Where's x squared plus 1 here?
On the inside.
On the inside. X plus 6 is on the outside, x plus 6 for me was in the inside. But at the end, they both agree. It's just reordering things. Okay. it's sort of like if I said factor 18 all the way, and one person did 2 times 9, and then they kept going, and the other person did 3 times 6, and they kept going. Is one of them doing it wrong? No, they're both doing it right. They're both going to agree at the end. So it's sort of related to that. So what happens here? I'm gonna actually do this wrong on purpose.
2z minus 3?
More than 2 comes out.
6.
Yeah. But that's one way I could do this wrong is if I did take a 2z squared out, I'd be left with 9.
No, I just did it.
And then when you do this one, it's not going to match with this, right? So
Yes.
then that's the problem. Is I don't know. Are you guys cool with that? I don't want to write more of this because when you do this one, if you take out a 5, it's not going to match with these. So what the problem is saying is the problem saying, hey man, you did something wrong, and then you go, okay, thanks problem. But what I hate is when people find a way to keep going, and they actually do another step. They just kind of plop all this shit down there. I'm like, no, you can't do the next step unless these are the same. I like it. So they make a mistake a different way. So another way to make a mistake. What actually comes out here?
6.
6
Z.
z squared.
Oh, yeah.
2z.
So you guys might realize it's what I had over there. But if I make this mistake, if I take out a 5 and I get negative 2z
That's what I got.
plus 3. No.
Is that the same?
Is this the same as this?
No.
So not.
So,
Right? These are not the same, right? So what is this telling you? You forgot to take out a negative. That's what would make it the same, right? It's telling you, hey, you forgot to take out a negative. Don't just blindly put this down and this down and this down and just say, there you go, that's your math, Jeff. It doesn't make sense to do the next step unless these are the same. That's what allows the next step to happen. You guys see that? I desperately try to get you guys to not give me just all the shit. Here's all the shit. Here it is, Jeff. You pick out the right answer. No. The problem is being really nice to you. Oh, I should have taken a negative out because then that becomes positive and that becomes negative. Oh shit, now they're the same. So if I saw 2, 3, and 6, 9, oh, I forgot to take out another 3. So you take out another 3, not a big deal. So now what's the last step?
6z squared.
Okay, sure. We start to go there.
Minus
5.
2z.
2z minus 3.
Sure. And if you wrote 2z minus 3 times 6z squared minus 5, you're right, because multiplication doesn't care what order you do it in. 2 times 5 is the same as 5 times 2.
Step 2.
Say again?
Yeah, this one was minus. I didn't understand. How can I?
Oh, okay. So right here, when you're about to do this, you look here. What does this guy have? A 2z.
2z minus.
What do you take out of negative 10 to make it 2?
5.
Negative 5. Do you see? Once you do this, it'll tell you what to do to make this work.
So what if
I want a 2 there. I got a negative 10. I got to take out a negative 5 to make it 2, so it'll be the same as this.
So what if you got that wrong?
Well, shit.
It's like,
You got to feel really good about this. And how do you check GCF? Is there anything left? So if I did the first thing I did, and it was 6 and 9, you say, wait, 6 and 9 have something in common. I didn't take enough out. So you got to make sure that this is right, and then it's going to help you on the next one. So to make that negative 10z become positive 2z, I have to take out a negative 5. So now this becomes
2.
positive 15 divided by negative 5 is negative 3. When you take a negative out, all the signs change. So if you got this, don't give me that. Just plop it down there. That don't make any damn sense. You can't do the next step unless these are exactly the same. It's trying to tell you, oh shit, I forgot to change that sign. And I was thinking about this the other day. If you're sitting there thinking, all right, I know I got to do this to get my degree. What the hell shit is it? If you try to explain to like a math 80 student, they're complaining that, why do I have to know what 3 times 8 is? What's the big deal? Do you agree that, well, let me check this out. Do you agree that it's good to know what 3 times 8 is?
yeah.
In the real world, it's good to know what 3 times 8 is, right? So can you imagine some frustration on your part if you're talking to a math 80 student and they're like, why do I have to know this shit? My calculator does. Why do I have to know what 3 times 8 is? You're like, well, what would you tell them? Well, you need to know it, and not yet. I don't even know what 3 times 8 is yet in the real world. What are you talking about? That's bullshit. So what I'm trying to tell you is, if you feel that way now about this, it's because you're currently in this. You're not seeing what this helps us do later.
Okay.
All of chapter 7, I can't do any of it unless I know how to factor. So factoring is like a fundamental skill, right? Like balance or something, right? So it's just something I have to have so I'm able to do more interesting stuff later.
Like long division.
I like it. Yeah, the thing about division is interesting. Let me see if you guys get this. This is what chapter 7 looks like. And I know I'm jumping the gun, but not really, because we've already done some of the work I'm about to show you right here. Watch this. If I said, do this division, remember that beautiful long division? Why? Does anybody realize why I don't have to do that on this one? Yeah, because the top can factor, right? So if I said divide 27 by 9, would you actually go 9 goes into 20? No, because 27 has a 9 in it, right?
Yes.
And then you can cancel the 9 out.
Same.
So here, what is the top? We figured out what it is.
X.
It's x plus 6 times x squared plus 1 divided by. So what can you do?
Just
So
cancel.
the most immediate nice thing about factoring is, if I have a division problem and part of it can factor, maybe I can skip long division. That by itself should be enough to go, oh shit, this factoring thing might be alright. And that's just the tip of a humongous iceberg of shit that you can do with factoring. Okay, alright. Let me see. Oh good, so the book, alright, it does give you some with minuses in the middle. And notice how both of these are negative, so if I did switch them, I would still have a minus in the middle. But if this was a plus, I might first switch them. That's what I was saying earlier. If I can make it so I don't have a minus in the middle, I'll do that, so I don't make a mistake later. It's easier if this is a plus. So that option is there for you if you think about it.
Where do you do that?
Here it won't help. They're both negative. So, oh well. You just gotta power through it. Now you could maybe
You can switch them.
switch these around. Right?
Yeah, 15 minus 29.
Yeah. So, and you can see that would help you. But actually, it turns out that doesn't actually help you, to be honest. It's really only if these two work, it'll help you. Okay. So let me do this. I'm going to do a little bit of a preview of 6.2, and then I'm going to let us out.
So this is all 6-1.
That's all 6.1, yeah. Dude. Now let me realize how much time I've devoted to this chapter on the homework sheet. If you look at it, there's a lot of time devoted to this chapter, probably because of how important it is. All right. Let me ask you a question that seems completely unrelated to anything, what we're doing. Can you come up with, I want, and some of you guys will know what I'm trying to do. Can you come up with two numbers that multiply to 18 and they add to 11? Yeah, 9 and 2. I like it. You guys see that? Alright, so that was not too hard. So 9 and 2. Alright, let me ask you another one. And sit on this one for a little bit. Don't say it if you figure it out. Two numbers that multiply to... Alright, Jeff, you gotta make it work. Negative 54 and add to negative 3. Don't say it. Don't say it if you figure it out. Think about it for a second. Okay. Does somebody know it? Yeah, negative 9 and 6. All right. How would you do that if it didn't just come to you? You could take negative 54 and start to write it in all of the different ways to factor, right? I could say, okay, negative 54, how do you factor that? Well, it could be 27 times 2. Right? Or it could be...
Times negative 2.
Yeah, so -2, yeah. So, and then the next, as far as the negative goes, you would put it on both of them, because it could be either one is negative, right? I could have asked you what multiplies -454 and adds to be +3. My answer would have been 9 and -6. So the negative I can kind of float around. But there's no way in hell 27 and 2 is going to make -3. I don't care where I put the negative, right? So there or there, it don't matter. That's not a good one. So then maybe the next thing I think about is 6 and 9, and I go, oh shit, that would work. That would make -3 if the big one's negative. Cool. How we doing so far? All right, so one more of these. What about multiplies to, what you got, Jeff? -60 adds to 11. All right. So everybody figured it out. Oh. So let me show you something. Does anybody realize what I'm doing right now? If you've done factoring before, does this sound familiar? You need two numbers that multiply and they have to add to be something else. All right, some of you guys realize what I'm doing. But this skill by itself is something I could have asked my Math 88 students, right? They should be able to kind of figure this out. So this is like a Math 88 level skill in its own right. But this is going to help us factor some stuff later. Instead of writing all the factors of 60, because there's a lot of them, and the answer is one that we don't normally think of immediately, I can instead start with, well, what numbers add to be 11? Now, you got to be careful. I can't say 5 and 6, because one of them has to be negative. So let me start this off. So like, what you got, Jeff? I don't know, Jeff.
-4, 7.
So they have to add to 11, and they have to. One of them's got to be negative. So it could be, for example, it could be 9 and -20 or something, right? Or -9 and 20. Does that add to be 11?
Yes.
Yes. Does it multiply to be 60?
No.
No, it's too big. It's like Price is Right now, so take it down. So maybe -7 and 18. Does that make 11?
Yes.
But it multiplies to be something. 126? Yes. Do you guys see what I'm doing right now? I need two numbers that do both of these things. But most of the time when teachers teach this, they focus totally on writing the products and then checking to see if they add. That's silly to me. It's easier to make numbers add to be 11. So eventually you get to -4 and 15. Those add to be 11.
60.
And they multiply to be
60.
-60. Yeah. So that would be the two numbers that do what I want it to do. So how does this play into factor? Yes, sir.
So this is like division where you have to guess.
Yeah, at some level you're guessing, but my first guess, when I multiplied them, they came out to be way too big. So that tells me I want to make the number smaller for the next guess. So thankfully it's constrained.
To get to that -9 to that 20, you're kind of guessing until you make some progress. And then
Exactly. So your first stab is a complete guess. And then you refine your guess based on what you get. 11. Kick ass. Exactly, yeah. So, let's see where this ties into factoring. Alright. Just make you feel like you're in acting class.
What is my motivation for this thing?
When I factor something, I'm undoing what? Multiplication. I'm undoing multiplication. So to investigate factoring, I actually can look at some multiplication problems to see how it works. So I can try to see how is it going to work backwards. So when I multiply, for example, x plus 4 times x plus 3, what do I get?
X2. X 3x.
Alright, is everybody cool with that? So then I get x squared plus 7x plus 12. Let me see if I can get you guys to understand what I'm about to say. Looking at the problem, where exactly did 7 come from? 4 and 3 had to be 7. Where did 12 come from? 4 and 3 multiply to be 12. So two numbers that multiply to be 12 and add to be 7 would be the answers here. That's why that whole thing I did earlier is exactly what you're going to think when you do this. So another problem, let's see. X minus 7, x plus 5. I get a start. X squared. It's 5x. Minus 35. So x squared minus 2x. So again, where did the negative 2 come from? Negative 7 and 5 added. Where did the negative 35 come from? Negative 7 and 5 multiplied. Right? So what I'm doing this for is to figure out, is there a pattern, is there a process I can figure out to go backwards? If I give you something like this, can you figure out how to write it like that? So let's do that. Sure, Jeff. All right. So what have I had? X squared plus 6x plus 8. So I really want you to understand how this works. X squared is the easy part. What makes x squared? X times x. So I'm always, when there's a 1 here, it's easier. So the next level would be, what if it wasn't a 1? But right now it is a 1, thank God. So x squared is x times x. So what I'm trying to figure out is what goes in those blanks to make these numbers work. But I know that whatever's here must be the product of these two, and whatever's here must be the sum of these two. So it turns into what two numbers multiply to be 8 and add to be 6?
2 and 4.
2 and 4. Plus 2 plus 4. Done.
And the order, it doesn't matter.
Doesn't matter. I love it. So x plus 4, x plus 2, same thing. Because 8 times 7 is 7 times 8. For example. And just to remind you, this is Jeff's weird shit here. If x were 2, what number is this? 4 plus 12 plus 8, which is 24. If x is 2, what's this? 6
plus 4 times 4.
And 24, a way to factor it is 6 times 4. So again, when you do this, and that was actually relatively easy, hopefully some of you guys agree, you're actually factoring an infinite number of numbers, because what could x be? An infinite number of numbers. That's crazy. So you say to your friends, what did you do this morning?
Oh, I got out of bed late.
I factored in infinite number of numbers. So thank you very much. You're like, holy shit, okay, whatever. Alright, that's plenty for today. So that's section 6.2 really. I said we take a little baby step into it. We're going to do more, obviously, next time. Oh!
Quiz?
Yeah! Quiz next time. Quiz
Tomorrow.
next Tuesday.
Chapter 5.
Let's see. Yes. All of chapter 5. Oh, yeah. All right.